Well, that was different. As you know, here at Artisan, we do lots of projects with renewables, but this job has been a new challenge for us. We're here at one of the biggest garden lighting projects we have ever done. In this video, we're going to show you the whole project from start to finish, which has been going on for months now. We're going to show you how we managed to pull it off to the Artisan standards. So make sure you like and subscribe, and let's roll the intro. So let's jump back to 9 months ago when British summer was in full swing. Let's join Lee, Luke and Ruben on the first day.
All the ducts are in now, so what we're going to try to do today is put some blue rope in most of the ducts ready, and also where we can pull some cables through, just so next time when we come we can start second fixing bits. That's a good little Instagram shot, isn't it, on the barks. Stick that in your video. Right, so this garden is huge.
So like me and you are going to be friends by the end of the day.
There's already the little ones that come with it.
Yeah, there's quite a few here.
This one?
Give it a pull. Yep, got that one.
All right, so shall we tie one of them armords onto this?
Yeah.
Balling.
Yeah, beautiful place this, huh? Shall I show you what we're going to do? What lights we're going to do?
Yeah, was it some down these steps?
Yeah.
And some round them round the little steps around there?
Yeah, so on the steps here we're going to have really nice, like, sort of stainless steel lights or something just on here, shining down, casting a bit of light over the steps. I think 3 or 4 of them along there.
And are these all going back to the control box on the fence?
Yeah, so it's all going to be low voltage LED. Yep. Hudson Lighting, have you seen them on Instagram? Yeah,
they're really good, good quality.
Really nice fittings, like all kind of handmade. So you can do, with a constant voltage driver, you can do like a loop basically. Yep. And you can have a loop like as long as just you like going. And it doesn't affect, like there's no issues with voltage drop or anything.
Oh wow.
Nick Bundy's just tried to call me, so I'm going to see what he wants.
Welcome to the EE voicemail.
He's not even got a special voicemail. Hey mate.
Hello mate, you okay?
Good, yeah, how are you?
Just make sure it like goes like that, because otherwise it's gonna maybe leave it on the floor and just like unravel it.
We're doing a little filming job today, so you're gonna feature in the video now that you've phoned me. So.
Oh, great! Nick Brody rings for help is gonna be the title.
Yeah.
Great. Yeah.
How'd you wire up a socket again? Trying to push it.
Yeah, I mean it's gone further than this.
Okay, not bad. So this is our main cutout, and on the other side should be the consumer unit. I was just going to have a little look to see what's what here, and actually it's quite interesting because it's a 3-phase head, but they've only used 1 phase, so they do have potential for 3-phase if they wanted to later on. Quite surprised that they've not used it really because it's such a big house. Let's go and have a look at the board. So this is the main consumer unit, quite a big one, even though it's single-phase system. They've obviously put a 3-phase board in but linked out the phases, I would guess. We're searching for the cable that does those outside lights, but I can't see a circuit that is labelled as garden lights. It might be lights new, potentially. Now it's time for neat or not neat. Wedged with the tightness. There we go. Well, it looks like Corey's been here. Makes me want to vomit all over myself. Like, what the heck were they thinking? I mean, look at all that exposed copper, and the wires are just not, nobody's even tried to straighten them up, you know? You've got a mix of new wiring and old wiring, and to top it all off, they've taken the tails through separate metal grommets, which is actually very naughty because you can get eddy currents, magnetic effects, thermal effects. You can actually get issues potentially with that, so that is against the regs. I mean, it's just such a tragedy to have such a big, beautiful board like that and it just be thrown in without much care and attention. But anyway, we're gonna have to turn a blind eye to that for the moment and focus on what our mission is, which is Where does that garden lighting cable go?
Jordan's swanning around somewhere, not helping us. Oh, but we're just getting some cables through the ducts ready. We're just pulling some thick blue rope through the other ducts, just so when we come back, we're just ready to tie on, because don't really want to trust these little thin black ones that are already there for us. But yeah, we're going to pull these all in, and then at least it just makes things easier when we come back. Did he not buy one on a wooden drum? Best walking back with it.
No, but you can't.
Yeah, like that, just keep...
Yeah, but how? Can't get your arm through.
We'll just keep like...
It's not a drum, it doesn't work like that.
Yeah, but your hand's through the middle. Your hand is the drum.
Please look, just try and act like a drum on there.
See? What?
You got like 10 steps left.
Yeah. Look.
Did I get a bit and go, look, I'm wrong here, I'm wrong.
Mate, I've done this thousands of times.
5 foot.
Right, let's just unravel it.
So I've got to go and have a massage now, so I'm going to leave these guys to do the hard work and see you all later.
Look, I've got the other end.
Mate, it looks like a, you know, the big boats where they're woven, it's that tangled, you know the big
It's just one big rope. I mean, I would have bought one on a drum, to be honest. Mate, stop playing with the chickens, let's unravel this rope. Max is loving this. The comments we're gonna get.
No, just cut this, just do timer.
So having got all the prep work done, we had to wait a little while before continuing with the project. And once the landscapers had got all their jobs done, we returned in December 2022 to crack on with the electrical work. We sent our cameraman Max along to film the next big stage of the project, and he brought with him a special visitor.
Just be like, have some sweets. Have some sweets.
What, oh, they're quite good as well. Chinese.
No. You guys have them. It's fine. I've got loads of them. We don't stop.
Alright, welcome back guys. It's late December, last job of the year hopefully, and we're here with Chris from Hudson Lighting, and we're going to be telling you why it's best to run extra low voltage lights rather than mains voltage lights in the garden. Okay, so we're here at the main entrance. As you come down this lovely long driveway, you can see you've got these old fittings that are no longer in use. So the landscapers have put some ducts either side for us, and there's just going to be 5 either side, nice sort of spike lights shining in on the driveway. It's all on a Kinetic, so we're going to be doing a motion sensor at the top of the driveway, a motion sensor at the bottom of the driveway, and also a switch inside. So that's the great thing about using the Kinetic receivers. You can just pair all the switches, don't have to run any cables, and we can just place them where we want, so as they drive in or out, all these driveway lights are going to come on and just be a nice little feature to it. The builders that built the extension, they left an armour down here that comes from inside. What we've done is we've fed a socket with it and then a fuse spur, and then that fuse spur is going to feed our sort of garden lighting control box, which is over on the fence behind them trees. And then in there we've got 4 zones, a zone for each set of lights, and then we've also got a spur that is going to feed a pump for the fountain. So I'll go show you all the zones now. Okay, so over on this zone we've just got this nice stairwell, and we're going to drill in 2 eyelid lights, which is just going to sit inside the sleepers. As the sleepers disappear up the top, we're going to actually have spike lights which point down towards the stairs. So if you remember the video earlier in the year, there was a massive mud pile here, and Jordan said if the video hit enough likes, he was going to swing into the mud pile.
How about this? If we get 2,000 thumbs up on this video, then in a follow-up episode, I will swing into this mud pile.
Unfortunately, the mud pile's gone now, it's all turfed. So let me know in the comments below if you can think of a better forfeit for him when he comes back from his holidays, I'm thinking maybe jumping the water feature down there. So yeah, let me know what you think. We'll have a look and see if we can come up with some ideas. Okay, so this is another one of the zones. So we're going to have 2 spike lights on either side. Each of the spike lights have a 2-meter flex, so we've got a bit to play with. It will look good once all this mud's sort of cleaned up and landscapers have finished, and they're just going to be putting some light onto the stairs. Along this path we've got another zone. We've got 3 of these spike lights, which obviously we need to bury the Copex, get the whisker box mounted on the back of the sleeper. These can be angled to light up the pathway. We've got 3 coming around here, and then at the end of the pathway before you get to the water feature there's just 1 more that's going to light that area up, or it might light Luke up on his phone. Alright, so we're over at the water feature, not filled yet, but I think it's going to be quite just a still water. It's got a slow pump that's going to stop it going stagnant, and it's going to be reflecting all of the, what do you call it, rock face. It's going to be reflecting all of that, so there's going to be some trees just behind the seating area. So I think we've got 2 spike lights over there which is going to light up the trees a bit, and just another one over in this area, and that's all of the zones covered. So if I go show you the control box. Alright, so over at the fence, we've got this big enclosure mounted up. These ducts are going to have to be neatened up and buried a bit more, but if I open it up, so from the house where there was a fuse spur, that's going to feed in. We've got a local fuse spur which is going to be feeding these Connect receivers, 1 for each of the zones I've just showed you, and then them receivers are going to go into the LED driver. We've got a dimmable one as well for one of the sections, and then out of there our extra low voltage cable, which is these ones, is going to go off to each of the zones and feed the lights. So I just need to spend a bit of time here, get that all wired up, make it all nice, and then try and neaten up them ducts a bit.
Hey guys, I'm Chris Hudson from Hudson Lighting. I'm a British lighting manufacturer, and I'm here doing a shoot with Artisan Electrics. Here's an example of one of our spotlights that we do. It's a lot smaller than you're normally expecting to see, way smaller than normal GU10 spotlight and smaller than your typical MR16, etc. Yet this will produce more light output than you'd expect. So guys, I want to tell you exactly why 230 volt spotlights are really bad in gardens. Essentially, I was an electrician for over a decade, and I was installing garden lighting for a majority of that time. And we installed GU10 spotlights here, there and everywhere, and they just caused us no end of issues. But critically, there's a few safety issues with them. You may have seen in the papers a few years ago a young boy that was killed in a pub garden. I know it wasn't a spotlight, it was a wall light, but still the same premise applies. And from my own experience, I actually did an inspection on a particular house. There was some garden lighting in there. We deemed the whole thing unsafe. There was quite a few issues there, and essentially what happened was there was someone doing maintenance in the house, and they were throwing buckets of water over the garden. I know it's a 1 in a million chance, but basically the electrical current managed to travel through the water, through the bucket into the person, put them in hospital for 3 days. And my report went in, and he took the landlord to court and got a significant settlement in place of that. I just don't think that 230 volt garden lighting should be a thing at all. It should be extra low voltage. So please, please, please install extra low voltage in future. Right guys, so we've got a supply position over there. So we're just going to mark a supply over here. I'll just crop it out with an S. There we go. Now, along here, we've got a pathway that runs. So if I just draw this, now my drawing's terrible, so sorry in advance, but basically the pathway goes something like that, and we've got the water feature, etc. back here. Well, if I just run that pathway through like that, we've essentially got a spotlight here, a spotlight here, a spotlight here, and a spotlight here. Well, these are actually pathway spotlights. Now, the way you'd wire these, essentially, is a cable coming out from here, and this would be pretty conventional to how you'd wire most other lights, out to here, out to here, and out to here. So that's just one particular zone. Now, the type of cabling that you actually use when you're doing extra low voltage lighting is very different from what you would use when you're doing low voltage, i.e. mains lighting. So when you're doing low voltage mains lighting, what you'll do is you'll run an SWA. So we all know an SWA, steel wire armoured outer sheath. So if you go through the cable, you hit the earthed outer sheath first, and you're not seriously injured or killed. The idea anyway, obviously with RCD on the back. So you'd have that SWA running out to all these positions, you'd have a joint box, and then you come out with each of your lights would be just a flex. Now the problem is you've gone all to that effort with an SWA, and now you've got this spike light that's got just this flex. If I just take, for instance, one of these spikes, now you imagine if this was a GU10 spike light, the flex is pretty similar. Now this flex, if I go through it with a shovel, that's a really big problem. With extra low voltage, we don't have that issue. If we go through this cable, we're not going to have any major shock risk or anything like that. The risk is mitigated completely. That's your typical armoured cable that you're going to use when you're running low voltage lighting. And this little cable here is really what you quite use for extra low voltage lighting. Now, the installation difference in terms of both cost and time saving is massive. You know, whenever you do an armoured, when you've got to make off an SWA, it takes time to make off that gland. Probably 15 minutes for some of you. Some of you are going to be going, nah, you know, it's 2 minutes for me, mate. You're not 15 minutes, but you know, there's some of you out there it's going to be 15 minutes. Flex, Stanley knife, or even just automatic wire strippers, straight away, straight in a box. It's just so easy. And the cable, the price difference is quite big. I think 1.5mm 3-core SWA is about £1.70 a metre. Someone will drop it in the comments and let us know. 4-core 0.75mm PVC flex, we're looking at about 50 quid a drum, 40 quid a drum, something like that, for 100 metres. So there's quite a bit of a price difference between the two. What we've got here with what Luke's done is basically he's taken 20mm conduit, 20mm flexible conduit, and basically run that 4-core 0.75mm flex straight in that conduit. It's going to run that up to the whisker box, so it's mounted it on the wall, because it's always best to try and keep your whisker boxes off the ground if you can. So in this case, we're mounting it on the wall. There is another option, the whisker spike. So this spike is fantastic. If you've got nowhere to actually mount the box, you can use this spike to actually keep your box off the ground. So basically that goes in the ground, he says, and then you mount your box straight to that, and it just keeps it dry effectively. It's best to mount the box like that if you can. If you absolutely have to mount flat to the floor, then you want to be gelling those boxes, even if they're extra low voltage. That's really important. So we've got a supply position here. We've got all our ducts coming in that landscapers have actually installed for us, so that you can actually get all your cabling out to each area that you can't actually access otherwise. So in here, Jordan did a fantastic neat layout and Lee's executed that. And essentially we've got our load cables going to all our lights. So everything going out here is extra low voltage. There is no 230 volt going out from here. There's a 230 volt feed coming in armoured, buried appropriately at 600mm deep. But for extra low voltage, it's all going out for the rest of the garden. You've got Quinetic switching here. One of these is dimmable, and we've got our normal switching LED drivers here, and a dimmable driver just here as well. And then we've got our fuse spurs just to feed that all in, and it's going to be such a nice, neat installation. It's very rare that I get to see something as good as this. So great job, Artisan.
I'll just mount the whisker box here. This is a feed in, this is a feed out, and then this is a supply to the light. So he was actually just discussing, these we're going to permanently bury under the ground, but with this a feed to the light, because when the bushes grow and things like that, you might want to move the spotlights around a bit. So we're going to bury these underground, and then these, when they're connected, this is just going to lay lightly on top of the surface, because I think they're going to have like bark chippings and things like that. So if we keep this on the surface, that way they can just move the lights around to suit the garden really, and what's best for that.
Okay, so this bit's on definitions with regards to extra low voltage and low voltage. So extra low voltage is anything less than 50 volts AC, and sorry, that's more than, I've just put more than, less than 50 volts AC, and less than 120 volts DC. Ooh. Okay, that's extra low voltage. Low voltage is more than or equal to 50 volts AC up to 1000 volts AC, and more than and equal to 120 volts DC up to 1500 volts DC. So as you can see from that, everything in this bit, everything that's low voltage, we're talking your normal sockets in your house, your normal lights in the house, we're talking 415 volt commercial, industrial, we're talking trains, DC trains, train lines, etc. That's everything that comes under low voltage. The problem is that everyone says, oh, let's go and install low voltage lights. what do they actually mean? They mean 12 volt and 24 volts. They're actually talking about extra low voltage, not low voltage. I'm just doing art attack, right? Hang on, we just draw that box there. We've got the tree up this way, and then there's Lee there, and he's holding his cable there. Yeah, okay. And we've got some nice bushes over here and over here. Yes, there we go.
On this canvas, you're the creator. Anything that you want, you can build here. This is your world.
Right, so there's a few different ways for extra low voltage in terms of what's available to you. You've got parallel wiring, so that's your conventional. So we've got 12 volt, 24 volt, 36 volt. Those three are pretty standard. 12 volt is the most common extra low voltage in terms of parallel. So what I mean in terms of parallel is you take all your browns and your blues together, you take your reds and your blacks together. So that's your standard parallel wiring. Then we've got series. My writing's getting worse and worse as we go along this. Series, you've got 350 milliamps. And you see this is in current, not in voltage. 700 milliamps, 1050 milliamps. Okay, so there's just standard series wiring. Now, the advantages versus disadvantages for series versus parallel. With parallel at 12 volt, from transformer to last light, typically 30 to 50 meters. If you go longer than that, what happens is your lights that are further away from the transformer start to get dimmer. The same with 24 volt, except 24 volt you can go roughly twice the distance. 36 volt again, same deal. With series, what happens is the drivers actually work to make sure that every LED sees exactly the same current, so that there is, over their entire distance, they don't see any dimming. So from the first light to the last light, it's exactly the same brightness. 1050 milliamp, you can run from the driver to the last light about 500 meters. 700 milliamp, you can run about 700-800 meters. 350 milliamp, from driver to last light, you can run 1 to 2 kilometers. And just to add, that's at just 0.5 mil of conductor. Up here, for the 12 volt, 24 volt, 36, you really need to be 1.5 mil of conductor. So you're saving on your cable costs down here. 350 milliamp is what I really recommend, extra low voltage. So on this job, we're using 350 milliamp lights. We wouldn't have to, we could get away with 12 volt or anything like that, but 350 milliamp is also really energy efficient. With 12 volt lights, what happens is you actually, with LEDs, they're actually normally running 3.3 volts per chip. So a typical 12 volt light will actually run at 9.9 volts, then has a resistor to drop the other 2.1 volts, which makes it really inefficient. With a 350 milliamp light, actually we're just powering one single LED. Could be multiple, but we're making sure that that LED is just seeing the current and we're not wasting any power. The losses are just at the transformer or driver. Okay, so in terms of actually the wiring, when you've got parallel, what you have is you've got your red and your black cores, so I'm going to be fumbling about with these pens a bit. Red and your black cores from each light. Let's say we've got feed in, feed out, feed in, feed out, okay? For your positive, you're just going to literally just run all your reds to your positive, and that's your parallel wiring, right? And then for your negative, if this was your negative here, so that's nice and simple. All positives and all negatives go together. So that's your 12 volt, 24 volt. If you're doing 230 volt, it would be like that. Obviously, bar we're missing your CPC there. So I've got some 5-pole Vargos. And if you were doing these in parallel, what you would do is, this is our feed in. And forgive me for not having a crimp. But yeah, nice little. We're going to wire all our reds together and our brown in. And then we do the same with all our blacks. So we all know that as our conventional wiring, if we were doing 12 volt, 24 volt, or if we were doing 230 volt, that's how we would do it. Now with series, it's a little bit different. So with your constant current wiring, if you've got 4 cables coming in, like this. So if this was our feed in, we're gonna go from our red into our red of this light. From our black of that light, so let's say this is light 1, we're going to go into the red of the next light. So say this is light 2, and then we'll say this is out. From our black into the red of the out, and link the black together. So you see it's a big daisy chain. That's how you do series wiring. Feed in, out to our first light, feed out from our first light into our positive of our second light, from the negative out of that last light. And the reason I show you it's easy is because it makes one continuous loop. So that's how you can see that you've wired it correctly. You can see that I've come in, into this light, out of that light, into this light, out, in, out, and back again. So that's your series wiring. That's when you're connecting it up series, that's how you need to connect it up. So the only disadvantage with series wiring is that you've got an issue called hot swapping. So what hot swapping is essentially, we all know, we've all done it, 12 volt, 24 volt lights, 230 volt lights. You can work with them live. I mean, you shouldn't be working 230 volt lights live, but 12 volt and 24 volt lights commonly will connect and disconnect while the circuit's actually on. With constant current, if you do that, it's called hot swapping, and basically what it will do is it will damage the LED on the fitting. So essentially the LED driver tries to maintain the current at all of the different fittings at all times. When that circuit goes open, the driver will output something like 2 amps instead of the 350 milliamp, and essentially when the circuit closes again, it will bring that back down to 350 milliamp. But the time that it's at 2 amps, even though it's a split second, is enough to blow up the LEDs. So if you've ever done that with any brand, you'll know exactly what I mean. When you might have thought the light was faulty, it actually wasn't. It was actually that it was hot swapped. So guys, in this package is one of our pathway spike lights. So if I just peel up this lid here, and just pull out one of these. This is for the front garden. So this is in NATO green. As I say, this is British made. So essentially what I set out to do was create something, not only bringing back British manufacturing, but also make sure that everything is IP68. So one of the things that I suffered with was water ingress issues with lights that I used to install. So these are all IP68, but really importantly, the LED is replaceable, as is everything else. So if I just undo this little top here, and in there is our LED that's fully replaceable. That little plate comes off as well, if I can get it off. Fiddling about with it, there we go. And there's the LED itself, and that just comes out with just a small pair of pliers. You pull that straight out and that's replaceable. The other thing is that with these lights, with constant current lighting, what happens is when you normally connect them back to front, with a few brands, I won't mention their names, but essentially if you connect them back to front, you blow them up. With our brand, if you connect them back to front, they come on red. So basically you can easily determine which light you've connected back to front and correct that. But also at night, if you wanted to change them all to red, you could just flip the polarity and have them come on like that. So as I say, we make these all in-house. They're all CNC machined, all powder coated, anodized, all electronics, everything is done in-house. And we're just made just south of London in Coulsdon. So guys, this is where we're at right now, what you can see behind us. We're gonna be back in a month, but for you, that's gonna be 1 second.
So that was the lights going in, and I'm here to inspect the finished product, and I have to say, I am really impressed. Excuse the sound of the hot tub in the background. Customer's getting it warmed up for us with a bottle of bubbly shortly. This project wasn't an easy one, but with their help from Chris from Hudson Lighting, we've been able to get an amazing bespoke luxury garden lighting installation done for the customer, and they're really happy with it. As the trees and bushes grow up in this garden, it's only going to look better and better. So if you've enjoyed this video and you'd like to get a bespoke luxury garden lighting quote for your home, please do get in touch using the links below. But either way, thanks for watching and see you next time.